Hello everyone. Today let's solve the problem lost numbers. So this was asked in educational code forces round 65. This is rated for the division 2, right? So this was asked in basically educational code forces round 65. So we will be solving the problem lost numbers, right? So you can just go through the question. This is easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, just give me a second, 1 second. Yeah, what's the problem state? uh, yeah, what is the problem state here? So we are given a hidden array of 6 unique values. We are given a hidden array of 6 unique values. What are the 6 unique values we'll be making use of here? Or what are the 6 unique values they have given? One is 4, another one is 8, another one is 15, the other one is 16, and the final two numbers are 23 and 42. Final two numbers are 23 and 42. So these are the 6 unique values. So 4, 8, 15, 11, 23 and 42 in the random order. So this will be given in the random order. These are the 6 unique values, right? So we can make up to 4 queries. We can make up to 4 queries. Just remember this one. This is very important, right? So we can make up to 6 queries, each asking for the product of any two elements. Each asking for the product of any two elements. This can be written as this one: a of I into a of j, a of I into a of j, product of any two values that they have given in the input, right? So the product of any two values, this one, that they have given in the this one input. So we are given a hidden array of the 6 unique values from this one 4 to this one 42, 4, 8, 15, 16, 23, 42 in random order. We can make up to 4 queries, each asking for the product of any two elements, just like this one I've showed here, right? This is just for the example sake, a of I into a of j. So what is our main task, or what is our main goal here? Our main task is to reconstruct the original permutation by using only those 4 product queries. So again, I'm telling, our task is to reconstruct the original permutation. So our task is to reconstruct the original permutation by using only those 4 product queries. By using only those 4 product queries. So this is very important. Again, our main task is to reconstruct the original permutation by using only those 4 product queries, by using only those product 4 product queries, right? So I hope the question part is completely clear, easy to understand, right? Let's come to the input output part here. You can clearly see here, right? So we can make up to 4 queries they have given. See here, 16, 64, 345 and 672, right? So we have been given in the input. We can make up to 4 queries, each asking for the product of any two elements. See here, we can make up to 4 queries. We can make up to 4 queries. These 4 things I'm speaking of. This is the numbers that they have given, 6 numbers they have given, right? 4, 8, 15, this one 16, 23 and 42. Leave about this one. We can make up to these 4 queries, each asking for the product of any two elements. This we can go with any two elements, product of any two elements, right? We have to reconstruct the original permutation by using only these 4 product queries, right? So we have to reconstruct the original permutation by using only those 4 product queries. Just keep this in mind, right? So it can be anything. So output, so there are multiple outputs for this input. There can be multiple outputs for this input. There is nowhere written that this itself is the output, right? So this is one of the output. So if you get the different output that matches accordingly, this one, the conditions in the question, so you can return that as well. You can just return that as well, the queries I'm speaking of, right? So this can be, instead of 1 1 2 2 3 5 4 6, it can be 1 1 2 3 3 4 4 5 as well. That also matches. You can just check with the same, right? So you can just check with the same what I have said. So that also matches. So you can just go with the output that also. For this particular input, 16, 64, 345, this one 672. So it can consist of any in any input basically, right? Most of the inputs for this question, it can consist of multiple output. Just keep this in mind, right? So we are done with the question and we are done with the input output part. So they have given us wonderful example just for the sake of understanding right here. So we are done with the input output as well as the this one, what do you call, question, right? Now let's discuss the approach followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach first. So here, I'll be considering the same first example for the approach. So they have given only one example. I'll be considering the same for the approach, right? See here, I have considered the same first example. So the output that we need to get here is this one. So this input has this one, multiple outputs. We can consider any output that matches the criteria or the condition, right, that they have given in the question. So it cannot be these four queries. There is nowhere written that we have to return these four queries itself, right, as the output for this particular input. So it should match the criteria or the condition that they have given in the question. That's it, right? So we will be going with a brute force along with the backtrack for this particular question, right? So the constraints are not that tight, right? So the constraints are not that tight for this particular question. uh, you can just go with a backtrack, or you can just go with a brute force and backtrack. Usually brute force with the backtrack is not considered that much ideal. So even though we'll be going with a pure backtracking, so we are understanding the backtracking, right? So the constraints are not that tight. We can just go with the this one, brute force along with the backtracking for this particular question, right? So here again I'm saying we'll be going with a backtracking. So here let me come to the step by step explanation part. So now we have query 1 2. We will be considering this out, 1 2 2 3 3 4 and 4 5 instead of this one. What do we call 1 1 2 2 this one 3 5 4 6. So instead of this one we'll be considering 1 2 2 3 3 4 and 4 5. So here we have to go with product of any two, product of any two numbers, right? So that they have given in the question. I'll just go with a of 0 into 0 1, this one 1 a of for this one. For the 2 and 3 we'll be going with a of 1 into 2. This for this a of 2 into a of 3. For this one a of this one a of 3 into a of 4. This has to lead us to 16 64 345 and 372. So this will be the output basically. For to get this output, what we would have done here is, so what we will do, we will brute force all the 720 permutations here. We will brute force all the 720 permutations here. As we are going with the brute force method, I cannot show you all the 720 permutations, man. I cannot show you all the 720 permutations. I'll just be going with the approach. You just understand this. You just understand this one. I cannot show you all the 720 permutations. So here in this case, we will brute force all 720 permutation in this case. 720 permutations, because we have six numbers that they have given in the question: 4 8 15 16 23 and 42, right? So this one will lead to 6 factorial, 0 of 6 factorial, nothing but 720, right? So that is the reason. So we will be brute forcing all the 720 permutations, and we will find the one where this one permutation of 0, this one, we have already written the answer. I have showed you here, right? So that is the reason I have showed you this one directly, the solution directly here in this part, right? So I cannot show you all the 720 permutations and then get the answer, as we are going with the brute force approach. So I've directly showed you the solution. Don't get confused here. So now we'll brute force all the 720 permutations, and we'll find the one where permutation of 0 into permutation of 1 will lead to 16 64 345 and 672, because this is given in the output. These numbers are given in the input, right? So this one we have to get by this one. You can consider this one similar to the sum formula, sum formulae, right? So permutation 0 into 1, 1 into 2, 2 into 3 and 3 into 4. So this one again I'm telling, this can be product of any two numbers. There is nowhere written that we have to go with 0 and 1 itself, or 1 and 2 itself, right? So you can go with anything, but it has to satisfy the condition that they have given in the question, or the criteria that they have mentioned in the question, right? So the output that we'll be getting here is 1 2 2 3 3 4 4 5, and finally we have to display all the four numbers, right? All the four numbers, 4 8, this thing, what do you call, all the six numbers basically, 4 8 15 16 23 42 in the output as well, right? So the output that we got here is, just give me a second, this one, query, just give me a second, 1 2 2 3 3 4 4 5, right? So the output that we got here is 1 2 2 3 3 4, this one 4 5. The output that we got here is 1 2 2 3 3 4 4 5, along with the this one, what do you call, just give me a second here, 1 second. So this one, six numbers also we have to uh, display, right? So this one, what do you call, 4, 8, 15, 16, 23, and 42. This one also we have to display in the output. If you see the output correctly, this one also we have to display in the output along with the four queries, along with the combination of the four queries, by which we get the product 16, this one 64, 345, and 672. We have to reconstruct, right? So they have asked us to, in the question, what they have asked basically, we have been asked to reconstruct the original permutation by using only those four product queries, right? So these are the four product queries we'll be making use of, right? So for the input, this thing, what do we call 16, 64, 345, and 672, we can have multiple outputs, so we can use multiple queries here. uh, Here in this case we'll be going with this one. So the output that we got here uh, is absolutely correct. The output that we got here is absolutely correct, right? So now, as we are done with the approach, or as we are completely familiar with the approach, um, let's discuss the complexities part. And one more thing, we are going with a brute force with backtracking. I cannot show you all the 720 permutations because we have six random numbers, and 0 of 6 factorial will lead us to the 720. So I cannot show you this one, so I have showed the solution part directly here. In this case, don't get confused here. Only thing is, we need to know, we'll be going with this with this formula basically. Permutation of 0 into permutation of 1, 1 into 2, 2 into 3, 3 into 4. And one more thing is, we can just go with any number here. It is nowhere mentioned that we have to go with the two numbers, but it has to match the output 16, 64, 345, and this one. 672. This is nothing but, initially we considered this one during the question, a of I into a of j, right? So this part, same thing goes with these three as well, right? So don't get confused here, right? So that's what, again I'm telling, I cannot show you all the 720 permutations, so I have just showed you the solution part directly here in this case. So this is the this is kind of a formula thing that will be going with permutation 0 into permutation 1, that leads to 16. Same thing goes with the other three as well. That leads to 64, 345, and 672, right? So I hope this approach part is completely clear. Now let's quickly discuss the complexities. Right? So the time complexity would be 0, this one, big of 6 factorial. The time complexity for the code that we'll be writing in the future would be big of 6 factorial. That is nothing but big of 720. Big of 6 factorial is nothing but big of 720, right? So we will be, accordingly with the approach, we are trying all the permutations once, and we will check each in big of one time. Right? So here the total time complexity will be this one, big of 720. Right? So the space complexity would be big of 720 as well, because we are storing all the 720 permutations in the memory. So we are trying with all the permutation once, right? So in that, this one, that leads to the time complexity of big of 720. And also we have to store it somewhere, right, in the memory. We are storing all the 720 permutations in the memory, nothing but here we are brutally brute forcing here all the 720, by storing all the 720 permutations in the memory, right? So the overall space complexity would be big of 720 as well. The time complexity and the space complexity for the code that we'll be writing in the future would be big of 720, right? Big of 720. So we are done with the approach part. We are done with the this one, approach as well as the complexities part. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So now let's start writing the code. I'll just come to the compiler here. So first, we'll be going with the input output. Means we'll be making use of the fast reader and the fast, this one, output, fast input and the fast output. For that we have to import input output, and also we'll be making use of the utilities, so we have to import the utility package as well, these two packages. So I'll just go with here, import java.input-output.star. This is fine. Import, this one will be java.util.star. This is fine. So next thing, let me go with the class main. So I can just give any this thing, what do you call, the class name. I'll just go with the main here. So what are the six possible numbers that they have given in the problem? This one, 4, 8, 15, 16, 23, and 42. Let's initialize that one to anything. So I'll just consider the variable nums here. So I'll just go with static final int. So this one nums, let me initialize this one to 4 comma 8 comma 15 comma 16. So this will be 23 comma 42. So this is fine. So this one, the next step will be, let's hold all the permutations of the six numbers. So this will be static final list. Stop this one int. So this one, this is fine. Let me go with the variable name permutations here. So let's create the array list. So this is the syntax, right? So array list, we'll be going with the array list. This is fine. So why we have made use of the array list, basically we have to hold all the permutations of the six numbers, right? So that is the reason we made use of the array list. So also we have to store the four queried products, nothing but in the approach, if you remember, we went with a1 into a2, a2 into a3, a3 into a4, a4 into a5. So for that I can write in this way, static. So this will be int. So let me go with the variable name products, and let me go with new int of, we are just going with the four queried products, right? So new int of, I can just directly give 4, right? So this is fine. Next step is, let's go with the main. Let's go with the main method here. So this one will be main. Let's make use of the input output exception as well, or else we'll get the error. So I'll just go with throws input output exception. So this is fine. Let me make this small x. This is fine. So within the main method, first thing is, as I've said, we'll be going with the fast input and the fast output. For the fast input, let's go with the buffered reader. So I'll just go with buffered reader here. Br equals new buffered reader, new input stream reader. This one we are getting this one from the system, right? So this will be system.in. So next, let's go for the fast output. We'll be going with the print writer as usual. So I'll just go with print writer. So this one will be output equals new print writer of this one system dot out. This is fine. So let me come out of this one. So first thing is, let's go with the first query, nothing but product of a1 into a2. We went with a1 into a2, a2 into a3, a3 into a4, a4 into a5. So let's write the first query and let's copy the same thing, as we are going with the brute force with backtracking, right? So first, let me write the first query, nothing but product of a1 into a2. So I can just go with the out dot print ln here, out dot print ln here, print ln, because we are going in the individual line. A1 into a2 is different line, a2 into a3 different line, same goes with a3 into a4 and a4 into a5, right? So I can just go with in this way. This has to be, we went with 1 2, if you remember, right? So let me use the semicolon here. This will be out dot flush. This will be out dot flush. This is fine. Also, let's go with the products of 0. Products of 0 equals integer dot percent. So br dot read line. This is fine. Yeah, this is fine. Next, this is it for the this one, what do you call, first query. We have to go with the second query, third query, and fourth query as well, right? Product of the four numbers, four queries. So let me copy the same thing. Let me paste here the same thing four times, three more times. So this has to be, instead of 1 2, this has to be 2 3. If you remember the approach, this has to be 3 4, and this has to be 4, and this has to be 5. This is fine. The same thing. This one will be product of 1 2 3 instead of product 0. For the first one, it will be product of 0. This one will be product of 2, and the final one will be product of 3. So integer dot passing, this remains same as we are going with the integers basically. This is fine. I hope the this part is completely clear. We went with the first, second, third, and fourth query. Nothing but product of A1 into A2, A2 into A3, A3 into A4, and finally A4 into A5. Now we will go with the chosen elements in the backtrack. So we have to go with the, let's go with the some variable. I'll just go with the name, use this one variable used to mark the chosen elements in the backtrack, right? So let's do that. So here, don't get confused, you'll get to know once I write the code. So here this will be boolean used. So let me go with the, this will be of the type boolean, so I'll just go with the boolean of 6. We have the 6 numbers, right? If you remember, this is fine. Now we have to generate all the 720 permutations as we are going with the backtracking, right? As we are going with the brute force. Here, I'll be making use of the backtrack helper method, and let's make use of that backtrack helper method within the main function here. So before right making use of the backtrack helper method, we have to write the backtrack helper method first, right? So let's write the backtrack helper method here. This is nothing but, let's go with the standard backtracking function, right? Because we have to generate all the permutations, or to generate all the permutations we'll be going with the standard backtracking function. So I'll just go with static void, this one will be backtrack, so this one will be int current, so this one will be boolean used, and finally int used. So this is fine. Int used, also we need the index, right? Also we need the index, so this one will be int index. This is fine. So within this method, what we'll do, let's go with the base case, nothing but when the permutation is complete, means here if index we are comparing, if the index is 0, then we have to add the permutation. So here I have misspelled, somewhere I have used the permutation, there also I have misspelled, man, where I have used the permutations here, right? So let me remove this y here, permutations. So this one will be, I'll be making use of the add keyword here. This one will be current dot, let me go with the clone, let me go with the clone here. This is fine. So we are not returning anything, so I'll just give return. So this is fine. Let me come out of this one entirely. Now we have to try placing each unused number at the current index. So that's what we are doing in the backtracking. That's what we discussed in the approach as well. Let's go with the iteration part, or let's move on with the iteration part. So this will be int I equals 0, I less than 6, and I plus plus. So this is fine. So within the for loop, so let me go with the simple if condition. If not of used here, used of I, if not of used of I here, within the if condition, what shall I do? So I'll just go with the current index. Let me assign this one to the nums of I. Let me assign to the nums of I. So this one used of I, let me assign this one to true. So here we are basically placing the each unused number at the current index, right? So here, this is the pure backtracking part. Iterated value of the used, we are assigning the true. Next, let's go with the recursion here. So backtrack uses recursion, man. This is the basics. We have to be clear with the basics. Backtrack basically uses the recursion itself. So here, backtrack of this one has to be current, comma used, and also let me go with the index plus 1. Let me go with the index plus 1. Finally this will be used of I, used of I, let me assign this one to false, let me assign this one to false. Nothing but we are backtracking here. This is fine. Let me come out of this one entirely. We are done with the backtracking basically, right? So now we have to make use of the backtrack helper method within the main function here. So we have, where we have left this one, boolean used equals new boolean within the main method I'm speaking of, right? So just give me a second. So where is this one? So here what we were doing basically in the line number 25, I forgot. So yeah, we were making use of the used keyword to mark the chosen element in the backtrack, right? So now we in this step, what we are going to do now, we have to generate all the 720 permutations. For that, we are making use of the backtrack helper method. So I'll just go with a backtrack here. This one will be new int of six numbers we have. I'll just give six here, six different numbers, and we have to go with the used as well, because the this one we have made use of the used here, this one variable, and we have to start with 0. This is fine. Now the next step is, for each permutation we have to validate the four adjacent products. Nothing but if this one we will be going with the for loop or the iteration part. Within that one, if you remember, we have went with permutation of 0 into permutation of 1. That should be equal to the index of this one, 0, products of 0, same thing, right? So permutation of 1 into 2 equals product of 1. Nothing but we are comparing the value here. The same thing, if you remember the approach, the last step that I've showed, right? The same thing will be articulating in the form of code. Now, for each permutation, we have to validate the four adjacent products. So this one for loop in, so this one will be permutation of permutations. So within this for loop, what we will be doing, if, so this one will be permutation of 0 into permutation of 1 equals this one, products of 0. So I'll just go with, and we have to include the same thing, right? So let me copy the same thing over here, man. So let me make the necessary changes for permutation. For permutations, we have to try the four products, right? So I'll just go with here. Just give me a second here. Let me paste it over here. Paste it over here. This has to be product of 1. This has to be product of 2. And the final one, we have product of 3. This one, product of 2, product of 3. This one itself we are considering right here. This is fine. This one will be permutation of 0 into permutation of 1 we are going with, right? So this one permutation of 1 into 2, this one will be permutation of 2 into 3, this one will be permutation of 3 into 4, right? We are checking for product 0 1 2 3. So again, this one we have to change. This is what I have said, one products of 0 1 2 3. So here we need to change 2, and the final one is 3. This is it. Now we don't need this one, and we don't have to include the last one, right? So this is the last one basically. This is fine. This is fine. So here after this, what shall we do? Let me open the we have written the if condition, right? I completely forgot. We have to open the this one, what do we call, mm, flower bracket basically. So within the if condition, if all the four match, then only we have to print the result in the required format, right? So I can just go with dot print dot print here. This one would be not, so this is fine. Just making use of the exclamatory mark here. So this is fine, exclamation, right? So let's go with the for loop here. This one will be int x of permutation here. So we have to go with out dot print. This is pure input output part, man, with a bit of logic. So this one will be x plus, we have to append the this one space as well. So I'll just be going with the string space within the strings here. So now, after doing these things, what we did basically here is, what we are doing here is, if all the four match, then we have to print the result in the required format. That's what we are doing here. So we have to output in the different lines, right? So we have to output in the distinct or different lines. So for that one, we'll be making use of the println. So this one will be print ln. This is fine. And the final part here would be, we have to always flush at the end of the interactive problems, right? So every for every problem we do, either we can go with the out.flush or out.close. So I'll just go with the out.flush here, out.flush here. So this is fine. I'll just give a return. We don't have to return anything here, right? So I hope whatever the code that we have written is correct, man. We are done with the coding part. So the same thing, whatever we discussed in the approach, we articulated in the form of code here. It's just that we made use of the backtracking extra helper method, so that it will be really helpful here. in this case for this particular problem. So we are going with a brute force along with the backtracking here. Pure backtracking, right? Pure backtracking, brute forcing and backtracking basically, right? So as the constraints are not that tight, we can just go with the brute force and the backtracking for this particular problem, right? So we are done with the coding. Before this one, what do we call? Before checking the code with the different inputs, I want to just copy paste the this one signature starter template. Just give me a second. So here in this case, I'll just come here. Let me paste this one, right? So just don't concentrate on this one. Let's move on with the logical part. So let's try with the different inputs. Let's see whether the code works correctly or not. So here, let me copy this one. Let me paste it over here. Let me run this one. What error we have? Method backtrack in class main cannot be applied to the given types. So here we have what? Why this error? Variable used is already defined in the method backtrack. Which one? Just give me a second. So int used this one. So here boolean used we have. So this one we are making use of it in backtrack, right? So int used, sorry, this is not required one. This is of the type boolean. This we have already made use of it in this one backtrack. So we want only the parameters current, used as well as the index. We have current, used as well as the index. This is fine. Let me run this one again. Now we have the real errors. Cannot find the symbol if permutation of 0. Huh? Variable permutation. So we have not made use of the permutation. Where is this? Line number 44. This I have given prem. This is not prem, man. This is perm. This is perm. Nothing but individual permutation of permutations. I would have considered permutation. This is fine. Now this has to work. Typos, man. Yeah. Now we are getting the output 1, 2, 2, 3, 3, 4, and 4, 5. Right. So 1, 2, 2, 3, 3, 4, and 4, 5. This works absolutely correct. So again, I have said you multiple times that this input can have multiple outputs. So this input can have multiple outputs. There is nowhere mentioned that uh, we have to get this particular output itself. 1, 1. These are the queries, right? 1, 1, 2, 2, 3, 5, 4, 6. So this is fine. Let me copy this one and let me submit this one. I hope this works, man. Let's see. So yeah, I have selected B already, lost numbers. Let's see whether this works for all the test cases or not. Let's wait for some time. Why am I feeling that this somewhere I have missed something? I don't know. Did I miss something? Yeah, we are getting the wrong answer, man. Let's check what is wrong here. Let's check what is wrong. So what mistake I have done here is in the line number 60. So here we are going with if index equals 0, man. So we have to generate all the 6 permutations and we have to store that one in the memory. So 6 numbers we have. So I have given 0 here. That is the mistake that I have done. So let me run this one. Now we are getting the same this one output. So just give me a second. I think this works. This has to. Let's see. So this is correct, I think. I don't know. This has to be. Let's see this one. Mm, let me move this one to here. This doesn't cause causes the problem. Let's see. Let me copy this one entirely and let me come here. Let me paste it. Let's see whether this works or not. So just wait for some time. What happened to this one? It is taking a lot of time, man. So let's do one thing. I'll just paste the code over here. 1 second. So let me choose B from the drop down. So what happened to this one? It is not allowing me to paste the code at all. Just give me a second. So let me paste it over here. So this one. I think this has to work. Let's see. Why can't I submit? Oh yeah, no, again I have to select this one. Let's wait for some time. You can clearly see here running on test one. Mm, Yeah, you can clearly see here running on test 17. So this was the mistake, I think. So here we have to generate all the 720 permutations, means 6 factorial. We have six different numbers, right? 4, 8, etc. So we have six numbers. So instead of 6, I had given 0, index equals 0. So we are comparing with the 0 number. So we are not generating any permutation at all if we are comparing with the 0, right? So we were checking for the wrong, this one wrong number. We were checking with the wrong number basically, or we were comparing with the wrong number basically. So that is the reason we were getting the correct output for this particular this thing, but still other test cases would fail, right? So here in this case, yeah, you can clearly see now the code got accepted. Whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear. Now again, I just want to say we have went with a brute force with this one. What do we call? Backtracking, right? We have tried all the different, or we were, yeah, we tried with all the different permutations basically, 720 permutations for the six numbers, as in the question they have strictly mentioned for the six numbers, right? So we went with the all the 720 permutations, as 6 factorial leads us to the 720, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.